All right, so as a fraction, describing change and for comparison. These are all things that you've seen in the news. Right? Layoffs, stocks, and trying to get people to buy their battery over other batteries. Has bad reviews. Now they came out with a new battery and trying to get you guys back to it. So an opinion poll finds that 35% of 1,069 people surveyed said that the president is doing a good job. So how many said that the president's doing a good job? Or do you guys just look at the 35% going, most of them say that they're not doing a good job? But that's not the question it was asking, right? It wants to know a number. So you're going to tell me what? $374, 375. Well, beside that 0.15 person. So we wouldn't round those up, right? Like we don't want 0.8 of a person, right? So now, let me ask you guys this. Do we know how to convert decimals to percent and percent to decimals? Yes? Okay, so if you look at it, do you agree that decimal comes before percent in the alphabet? Right, D comes before P. So if I'm going from decimal to percent, here, let me do it this way. If I'm going from decimal to percent, I'm going to the right, so I'm going to take the decimal point and move it twice to the right. If I'm going from the percent to decimal, then I would take the decimal place and move it 2 places to the left. So 35% would equal to 0.35 as a decimal. So if I'm changing from percent to decimal, I'm taking the decimal and moving it 2 places to the left because I'm going from percent to decimal. Okay? Just so you guys understand that. So in this case, I'm taking 35% of 1069. And what does the word of mean? It means to multiply. So I'll take 0.35 and multiply by 1069, and that should give you approximately 374.15. So we'll say 374. Okay? So let's talk about absolute change. and relative change. The actual increase or decrease from a reference value, which is a starting number, to a new value. So you have an equation right here. And you have an equation down here. Now this is the relative change. It's usually some kind of fraction or percentage. Now, do you guys notice that this top part right here is the absolute change? Okay. So apply that to, you bought a new laptop computer 3 years ago for $1,000. Today it's worth only $300. Describe the absolute and relative change in the laptop's value. Go. Yes? Oops. I forgot a piece. Questions? Do we know why the 300 came first? Because that's the new value of the laptop, right? And you're referring it to what it initially cost, right? The initial value. So essentially, you lost $700 in value after 3 years. Was it 3 years? Yeah. So the only time this is bad is what my brother used to do. He would literally buy a brand new laptop and then shove it in his closet and never open it. 3 years later, he brings it out and going, I can give this to someone. And 2 months later, it crashes. I wonder why, right? So he himself lost that type of money. He himself had a relative change of negative 70%. Just so you guys know, when they talk about absolute difference, it's pretty much the same. right? Because if you look at this formula here, doesn't that absolute difference look like an absolute change? It's just new value minus reference value, right? Instead of compared value. And relative difference, remember how I pointed out that they had compared value minus reference value here, right? Or new value minus reference value here. And I said, isn't that the same as this up here? They just made it different. Looks different, but it's exactly the same. Okay? Excuse me. Okay. Let's apply those formulas here. Recent data showed that California ranked first among the 50 states in average income at about $68,900 per person, and West Virginia ranked last at $46,600 per person. Do we understand why this is the case? Besides the fact that West Virginia sucks. It does. It really does. It really does. I've been there.
I'm assuming because California is a more popular state, and I know that they pay more over there because things are more expensive over there.
The cost of living is different between these two states. Humongously different, right? So $46,000 in West Virginia, you might be doing pretty darn well. Where the $68,000 in California, you might be just scraping by. Right? So you got to look at cost of living. Heck, cost of living in Naples versus Ave Maria is different. Well, Naples versus a lot of different places is different, right? This is the reason why the morning traffic from Fort Myers to Naples is awful. Traffic jams all the time because most people live in Fort Myers and come down to Naples to work. And the afternoon traffic from Naples to Fort Myers is awful because they're going home. Cost of living is different, right? Now, notice that part A. It says, how much lower is the average income in West Virginia than in California? So tell me what the absolute difference is and the relative difference is. Because this is now about which number to put where, right? Which one is the compared value and which one is the reference value. And this is where you kind of want to make notes on how it's said and what would be your compared versus your reference. So which one goes first, the 46,000 or the 68,000? Is the compare value 46,000 or 68? Does that make sense? Yes? How about part B? Does it change things? Do we just say it's 22,300 and 32% down, 2.4 down here? Why not? ¿Por qué? Yeah.
The absolute difference will still be right.
So now, in this case, it's not this way anymore. It is this way. So the absolute difference is still the same. Makes sense. What about the relative difference? How does that change?
Goes to 48-ish%.
The reason why it changes is because that denominator changed. Does that make sense? So you might want to put in notes based on what this is saying, which has to come first, which has to come second. Because that's what you guys are going to need to know. Do you guys think I need to put all 4 of these on the cheat sheet? Or just one of them? Or, I'm sorry, 2 of them. You want all 4 exactly the same written? If the new or comparative value is p% more than the reference value, then it is more than 100%. If it's less than, then it's going to be less than 100%, right? You just subtract that percentage. Right? So, for example, if I go out and buy sneakers that's $100, it's 25% off. How much am I paying? 75. Where do you get 75 from? Now, most of you guys would say, okay, 100 times 25% is $25. Then I'm going to take 100 and subtract the $25 to get $75. Or you can do what? If it's 25% off, what's remaining? 75%. So I will multiply $100 by 75% and get $75 to say that's what I've got to pay. I don't usually do the what's discounted and then subtract it from what's left, right? Like, that's not what I do. I will say, how much do I have left to pay, and I want the percentage of that. Jada earns 200% more than Reggie. What is Jada's income as a percentage of Reggie's? I already got one answer. Anybody else? Got a second answer. Anybody else? Yes? Because it's 200% more. So how many times larger is that? Oh, wait a minute. Look at that. Dang it. I gave that answer away, didn't I? It's like I knew I was going to teach that. Do you guys need this in the cheat sheet? Yeah? If the bank increases interest rate from 3 to 4%, the interest rate increased by what? Remember, there's an absolute and a relative, right? What's absolute? Increased by 1 percentage point, right? What's the relative? Yes? If you purchase a shirt with a labeled pre-tax price of $21, the local sales tax rate is 6%. What is your final cost, including tax? So you did $21 plus right? Hmm. Sorry. There we go. Or better yet, here, let me do it this way. So it doesn't look as confusing, because when I put that percentage in there, it looks different. Why is a 10% pay cut followed by a 10% raise a bad thing?
100 minus 10 plus then 9 is 99.
So you're making less money now. Because if you took if it was $100, you take 10%. That's $10 that you go, and then you're at 90. Well, 10% of 90 is $9, right? So you don't get that 10% back. It sounds good, but it really isn't. Less than nothing. Decrease caloric intake by 150% to lose weight. Oof. That means have your stomach eat yourself by 50% of your caloric intake. Yes? No? You don't want to do that? Eat yourself! Let's go! If 70% of the boys and 60% of the girls in class voted to go to the water park, then 65% of the students in the class voted to go to the water park. Bar? Not true, right? Not necessarily true. There can be a situation where that might be true, but majority of the time it's not. Heck, if we look in this class, the number of boys and number of girls are not even. So those percentages and those numbers will change as well. Ooh, look at what we're talking about here. These are going to be important definitions. Population. Sample. Population parameters. Sample statistics. So this is how TV ratings go. This is how they usually do TV ratings, right? They don't go and knock on every single door and going, what were you watching tonight? What were you watching tonight? What were you watching tonight? What were you watching tonight, right? Because that takes too much time. So they'll go down and they'll pick random houses in a random neighborhood and knock on a couple of doors and seeing what they are watching, right? And based on that, which is a sample, so it's a subset of that population, and then they make statements based on that population, right? Sometimes, like the polls for the elections are weird because you have no idea where they're taking the polls from, right? Are they taking the polls in California, in New York, in Florida, in Texas, right? Totally different. Yeah. We'll be talking about the biases as well. Absolutely. Absolutely, because that's important. Okay. Describe the population sample, population parameter, and the sample statistic. Agricultural inspector of Jefferson County measures the level of residue from 3 common pesticides on 25 ears of corn. From each of the 104 corn producing farms in the county. So what is the population here? Actually, not their farms. It's all the corn. All the corn. That's the population. Remember, population, we're not, see, the 25 is only a part of what was produced, right? The population is the whole thing. So again, if we were really trying to figure out what the TV ratings are, the real TV ratings, then we would have to go and knock on every single door and interview every single kid or every single person in that resident, right? In order to have a true TV rating. So it's about the whole thing. So yes, it's the ears of corn. All right, so what is the sample? The 25 ears of corn. What's the parameter? What's the population parameter? What are they testing?
Testing the 104 corn producing farms.
No. What are they testing? The level of the residue of the 3 pesticides, right? And the sample statistic is what? No, that would be the sample. The sample statistic would be what's actually in those 25 years of corn. What's the actual levels of the pesticides, right? Because if they were to test all the corns, then we don't have any corns to sell. Right? That's why they can only sample like 25 from this farm, 25 from this farm, 25 from this farm, 25 from this farm, and they test the residual of the pesticides and the average of them. They can say, okay, in this farm, it's at this level, at this farm, it's at this level, right? So they can actually talk about each farm and their levels.
Professor, can you go over what each thing was again? Just because I kind of missed a part of it.
Okay.
No, from the question.
Oh. So in this case, the population is all the ears of corn. The sample, we did the 25 ears of corn from each farm. The population parameter is the average level of the residue from the 3 pesticides. And a sample statistic is the actual measured levels.
Oh, okay, thank you.
So here's the basic steps in statistical study. Set the goal of your study, right? So in that one, the goal was to figure out what's the residual of the pesticides, right, of the 3 pesticides. Choose a representative sample from the population, because you can't take all the corn, because then there's no corn to sell. The farmers would just all be poor. Collect raw data from the sample and summarize these data by finding sample statistics of interest. The problem is that a lot of times what people do is that they see these numbers and then they not skew the numbers, but they correlate numbers together that they can skew their narrative a certain direction, right? Use the sample statistics to infer the population parameters and then draw conclusions. So based on their sample asking of certain households, what they're watching is how they come up with the TV ratings, and they infer that to what the whole population is actually watching, right? So each month, the U.S. Labor Department surveys 60,000 households to determine characteristics of the U.S. workforce. One population parameter of interest is the U.S. unemployment rate, defined as the percentage of people who are unemployed among all of those who are either employed or actively seeking employment. Describe how the 5 basic steps of statistical study apply to this research. So, step 1 was what? State the goal of the study. What is the goal of the study? To determine, well, the research is to learn about the employment or unemployment, right, within the population of America, of the U.S., right? Step 2 is to choose representative sample from the population. So what called sample that they took. Yep, the 60,000 households, right? That's clearly not our whole U.S. population. Okay. Step 3. Collect raw data from the sample and summarize these data by finding sample statistics of interest. So what is it? So the raw data doesn't come from the questions, right? It comes from the answer that's given for those questions. Make sense? And they're going to collect those answers and then determine the percentage of people that are unemployed or employed, right? In fact, in this case, because it says sample statistics of interest, they're going to collect that data and talk about unemployed. Step 4 says use sample statistics to infer population. So meaning, what they just did in step 3, based on those 60,000 people, they come up with a percentage of people that are unemployed, right? And from that, they're going to say, in the US, we're at this unemployment rate, right? And the scary part is this, is that if you had the money and you you picked 60,000 people, households, and you go out and pick 60,000 households, your data might be totally different, right? Totally different. Like if he did it in Naples, and you did it up in Lehigh, those numbers will be totally different, right? So we gotta be careful of that type of stuff. So now that's how you would draw the conclusion of what the unemployment rate is in the United States. So we have different type of sampling possible, right? There's a simple random sampling. We choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. Systematic. We're going to knock on the doors of every 10th house, right? That would be systematic. Convenience. Since I live in Ave Maria, I'm just going to ask people in Ave Maria. But is that a good sample size for Fort Myers? Probably not. Or even Naples? Probably not. Because the people who live in Ave Maria come from all different places, or I should say work in all different places, including Fort Lauderdale and Miami. Cluster. We first divide the population into groups or clusters and select some of these clusters at random. We then obtain samples by choosing all the members within each of the select cluster. Now, I would say that happens quite a bit. And then stratified. We use the method when we are concerned about differences among subgroups or strata. Within the population, we first identify the subgroups, then draw a simple random sample within each of that subgroup. Here's your biases. A statistical study suffers from bias if its design or conduct tends to favor certain results. Observational studies. And these are hard. These are really hard. But do not attempt to influence or modify these characteristics. It's really hard. Especially if you're convinced that one outcome was going to come and it's not doing it, and you kind of want your money to be worth it. These things always happen. Experiment. Treatment groups. Control groups. So when you guys look at research papers, all of these things are important to figure out what kind of studies there are, right? Because there are double-blind studies or single-blind studies, right? And they have found that most drugs with a placebo group, that the placebo group has the same results as the treated group. So they always talk about how the mind is that powerful, that if you think that you're getting the treatment, your body actually reacts to that treatment. It could be a sugar pill. But if your mind thinks it's getting it, your body is actually healing itself.
Interesting too. You can know it's a placebo, and sometimes the placebo effect still works.
Yes. And there's also things that are called nocebo effect. So a placebo acts in an active ingredient for the treatment, but it looks the same as the actual treatment. Placebo effects refers to a situation in which the patient improves simply because they believe they are receiving a useful treatment. And again, these are a lot of times they are, obviously if it's a pill of some sort, usually the pill looks exactly the same, right? So that people don't know the difference. And here's what I was talking about with single anonymous versus double anonymous, or single blind or double blind studies, right? Double blind studies is the best only because nobody knows, right? The nurse don't know, the doctors don't know who's getting what. Where single is very easy for someone to go, that's my uncle. I should just kind of push him that direction. Or even asking leading questions that changes the answer and not being right. And that all causes different biases. And that's always very dangerous. Okay. Let's see if we can see if there's any problems with this. A chiropractor performs adjustments on 25 patients with back pain. Afterwards, 18 of the patients says they feel better. he concludes that the adjustments are an effective treatment. Anything wrong with that? It's a very small sample. And is the 25 patients random? No, not random. It's his customers. Yeah, right? Because how many times do we go to a well, I don't know how many people go to the chiropractors, but how many people go to the chiropractor and come out and going, you're awesome, I feel crappier than I was, right? Usually you come out going, oh, that feels great, you got cracked, you're like, yeah. And then like 2 days later, you're like, oh, same thing is happening, right? So just because they're leaving and saying they feel better, it doesn't mean that is actually effective, right? And usually when you're going to get cracked, you're like, I'm going to feel better when I get out of this appointment. So there's a placebo effect there as well. So clearly, there's a lot there to be said. So in order for that to be the case, he will have to have like random samples, number one, have two groups. One that he's actually making adjustments to, and the other group that knows nothing about chiropractors, and he's just like making fake adjustments to, and then having results come out from there. Yeah. It'll have to be random, right? And I mean, it could be all of his customers, but he'll have to randomly choose who goes to the adjustment and who goes to the not fake adjustment to have that correlate. Look at this adjustment. Ooh. Doc, it doesn't feel like what was before. Like before I heard cracks and stuff. Oh, it is new. Okay, a new drug. For a type of ADD, it's supposed to make the affected children less disruptive. Randomly selected children suffering from the disorder are divided into treatment and control groups. Those in the control group receive a placebo that looks just like the real drug. The experiment is single anonymous. Experimenters interview the children one-on-one to decide whether they became more polite. Wow, this sounds like an awful experiment. What's wrong with this? It's random. It is single anonymous. That's an issue. What else? The parameters are awful. Well, not just that, but the experimenters are asking questions. Right? Like, you can come on going, you're feeling more polite, right? Right? Like, just the questioning is going to be different. Because I know that he had the drug. So I'm going to ask him a different way versus over here, I might say, you look like you don't feel very polite. I just asked two of the same questions, essentially, but turning one way and one the other way, right? And yes, the single anonymous is just a bad idea, period. Retrospective study. Such as official records or past interviews, and in which the sample naturally divides into a group of cases who engaged in the behavior under study and a group of control who did not. Huh? Well, that's the reason why it's called a retrospective. Right? It is literally something from the past. I'm trying to wrap my head around it, actually. A retro or case control study is an observational study that uses data from the past, such as official records or past interviews, in which a sample naturally divides into a group of cases who engaged in the behavior under study and a group of controls who did not. So this is a past case.
Doing a new study, but with past data from a different study.
That's what it sounds like, right?
Mm-hmm.
But are they going to redo the study? Or are they just
looking at the data and using that for your study.
so
No new data, for sure.
so this is almost like a peer review.
Yes, but you're using the data for something completely different.
Yeah. Because like a peer review, guys, like you will see research that is called a peer review, which essentially they're just reviewing what has already been written. And they come up with their own conclusion based on someone else's research, which is weird. Because it's going to say in the study. Right? It's going to say in the study. But I'm trying to see where I came up with these questions, though. I came up with these questions for a reason. Oh, so I'm wondering what kind of study these might be. So, so we talked about a bunch of studies. Do seatbelts save lives? So do you think that we can? But what I'm saying is, if it was an experiment, a study, are you going to randomly pick people and going, hey, you guys are a control group, you're wearing seatbelts. You guys are you guys are not going to wear seatbelts. Go drive. Doesn't seem very ethical, does it? Right? That's kind of nutty. Well, this is where, like you were just saying, what we can do is now do the retrospective study, right? So this will kind of put things better in perspective, more in perspective. Now we can kind of look at people who wore seatbelts, like see all these past accidents, and seeing the people who wore seatbelts versus the people that did not wear seatbelts, and how the severity of the crash was, right? So let's say that they estimated that this person was driving at 65 and a 35 and hitting a tree, right? So 30 miles an hour hitting, or 65 miles an hour hitting a tree with a seatbelt, 65 miles an hour without a seatbelt hitting a tree, and how that compares. So that's where the retrospective study would come into play. Okay? Because then the control group is, right? And the not control group is, and that will kind of naturally go that way. Is that fair? Can lifting weights improve runners' time in a 10-kilometer run? How many tree trunk leg guys do you know that go out and run?
Academy, we were doing that every day. Big boys in there.
Chafe Central. A lot of Chafe Central. So, I mean, you would literally just take random runners, put one group into a weightlifting program and one into a non-weightlifting program, and they're just running and then comparing the two. In fact, one of the things that they say is that 80% of the time that you train, you should be training in a zone 2 and not as a heart rate, but a lactate to get your best training. That's what they're doing with cyclists now, is having them training in zone 2 80% of the time. So there is certain lactates that your body excretes at a certain level of exertion. So they don't want that to be higher than a 2. When it goes higher than a 2, then it starts to really tire you out. So they want to, yeah. Can new herbal remedy reduce the severity of colds? What experiment would we do? Well, we want to use definitely a double blind or a double anonymous, right? We definitely want to do that, which most experiments should do anyways. All right, margin of error. I guess you guys are going to want this also. Is used to describe a confidence interval that is likely contained in a true population parameter. It's just plus or minus the margin of error. No, not the bell curve. Not the bell curve. So, let's take a look at this. So, an election eve poll finds that 52% of surveyed voters plan to vote for Smith, and she needs a majority, more than 50%, to win without a runoff. The margin of error in the poll is 3%. Should we assume that Smith will win? So the story from Joe Rogan was that Elon was looking at his phone, and before they called it the end of the day, who won the presidency, he left and said, Trump just won, and walked out. And everybody around him go, what are you talking about? How do you know? Here it is.
You take that 3 points in any direction, you have more of it in the 50% than under it.
Well, the problem is that if I take the 52%, add the 3%, I get 55. Subtract 3%, I'm 49%. True, but with the 49% as a possibility, even if it's 1%, is not guaranteed I'm winning. Does that make sense? So that's the reason why, if we go 52 plus 3%, 52 minus 3%, right? And because of that 49%, it's still too close to call. Okay. Now, if he was at 54, then guaranteed he's done, right? Even if it's 3%, because now it's from 51 to 57, there's no way he's going to lose. He's definitely won. Cool? Any questions there? Are we good to go? Wednesday we'll finish the last section. Okie doke. And let's go over like what we want on the cheat sheet on Wednesday. Is that fair? Okay? Yes? All right. Ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys on Wednesday. Later.